Hi everyone, welcome to topic number 3, Intro to Text Analysis. Today we're going to be talking about how to clean data, how to visualize text data, how to do things like computing word frequencies, doing sentiment analysis, and then also using things called regular expressions and grepl to look at specific patterns within text and also to clean text as well. How do we deal with text data? Most of you guys are probably familiar by now with a classic data frame. So we have specific variables that each have their own column, and then we have a ton of rows. And though the individual class of a certain column might be different, we can still typically do things like compute a mean, we can run models, things like that. But text data is a little bit different. So if we were to just run in a Harry Potter book, we would get something that looks like this. We have, a single variable and just text. This is super messy, and it's hard to know what to do with this when you just look at it initially. So we're going to talk about how to clean this data to get it in a form where we can actually answer questions about the data, and then actually talk about some of the things that we can do to text mine or to look at specific questions about the data. Okay, so we're gonna jump right into our R script. You guys will notice that we're gonna be relying on TidyText a lot. So TidyText is a specific, again, within the Tidyverse, a kind of a convention where each individual cell is a single word. And so for a lot of what we'll be doing, we will be working within like a TidyText format. So I've included a link here that kind of goes through more about TidyText mining, but until we will start looking at Trump's tweets, we will be tokenizing the books, which basically means turning the text into single units that are meaningful. Because as we saw from this little clip, this is not super meaningful. We can't really do a lot with this. So we'll be using the TidyText package a lot for most of the functions. Okay, so one thing that you guys will have to do is first install the Harry Potter package from GitHub. And the reason we're doing this is because it's not on the CRAN, but just make sure you only run this once, and then you should be able to load this Harry Potter library without any issues. But so I will go ahead and load my packages. And so when we load Harry Potter, we're getting within that package lots of different books. So for example, we might be interested in looking at the book, The Philosopher's Stone. So the first thing we want to do is just kind of check what kind of object we have. So if we were to run class on this, we would see that we have a character. And this is good because we can manipulate characters. If, for example, the entire book was a factor, we wouldn't be able to manipulate it because R wouldn't see it as individual pieces. It wouldn't see the sentences as different. It wouldn't see the individual characters as different. It would see it as a single factor. So this is good, and it should be a character, but if it's not, that's just one thing to check if you're having issues. We can also just use this glimpse function. This shouldn't be nested in each other. And we can just look at what the data look like. So we can see that we have just 10 of text, and we have 17 different rows. So what are these different rows? We can check that out by just looking at the data. So if we run this view, what we'll see is we'll see all of our 17 different rows. And if you guys are familiar with the book, you might already know what these different rows are. But one hint is that they all are capitalized, and it seems like the first sentence isn't. So if you still weren't sure, you could go look this up, but these in the Harry Potter library, the GitHub, but these are individual chapters. So there are 17 chapters in this book, and each chapter is its own row. So the first thing what we might want to do is just make that variable interpretable. So right now it's just called v1, which to someone who's not familiar with this data, it doesn't mean anything. So we will just want to redo this and create a new variable called chapter and text. So now the chapter is the corresponding chapter number, and then the text is all of the text that lives within inside of it. Okay, this is still not super useful. So we want to make sure that the individual stuff within this text column is actually meaningful. So what we're gonna do is we're gonna manipulate it further and create what are called a token. For TidyText, like I said, one word is a single token. And so what we're gonna do is we are going to manipulate the data such that every row is a single token. And in this case, a token is going to be a word. So to do that, we are going to use this unnest tokens function. And what that's going to do is that it's going to tell R to put whatever is in this text column into words. And we're going to specify that the new column, which is this output argument, is going to be called word. So again, what we're doing here is we're taking this text column, we are tokenizing it into words, and we are placing it in a new column called word. So if I show you what that looks like, we can see that now we have almost 80,000 different rows rather than 17, and we have an individual word in each of them. Something that might be helpful for other things though is you can use different types of tokens. So unnest tokens allows you to tokenize by sentences. You can also tokenize by tweets, and that preserves things like usernames and hashtags. Because if you guys didn't notice, what this unnest token was also doing behind the scenes is it was also changing everything to lowercase. So before, the boy who lived was all capitalized. And it's also going to be removing punctuation. And we'll talk about why this is important later. But like we know, R is case sensitive. So if it didn't change the case of these words, then the capitalized would be different than the lowercase. So that's something that's super important when you're working with text data. Again, you can also do this with sentences. And so now you have only about 6,500 rows. But let's just actually use the word tokenized version to do some word frequencies. So that's kind of a very common task that we would use within text mining is just to look at the word frequencies. So again, we're using a lot of dplyr to do some of these text functions. And so here what we're going to be doing is we're going to again read in the data, and then we're going to just count each individual word. And this sort by true argument is telling R to sort by frequency. So the most common words are going to be on top. So if we do this, we can see a column for n, which is the number of instances that word appeared. And on the left-hand side, we have the individual word. But we can see something here already that's a problem. The words that are on the top, things like the, and, to, a, these aren't really going to be meaningful for text analysis. And these are actually what are called stop words. So stop words are just common words that are not useful for analysis. And we don't want these in our data sets, at least when we're trying to look at things like word frequencies. So the way we're going to remove them is through a join. And so if you look at the help pages, you can see that there are a bunch of different types of joins. You can join two data sets completely, and this is super nice because unlike using rbind or cbind, the dimensions of the data set don't have to be the same. So even if you had 13 columns in one data set and 2 columns in the other, as long as you had a key or something that can match the data sets together. So if you had, for example, a participant number and you had the same participants in 2 different data sets and you wanted to meld them together, then you could use join. But what we're going to be using is this thing called Antijoin. And what Antijoin does is essentially you put in 2 data frames. So we have our book 1 tidy, which is the tokenized by word data set. And then we also have our stop words data set. And the order of these 2 is really important. So by putting this book tidy first, we're telling it to keep all of the rows in the X data set, and then any column that is also in the Y, we're going to remove. So if we had flipped the order, then we wouldn't be getting what we want. But basically what this is doing is any row that is in both the book 1 tidy and stop words is going to be removed. So we can do that with this Antijoin. And then if we were to look at again the word frequencies, we can see that now we have things that are real words. So we have Harry, Ron, Hagrid, like all of the main characters because they are mentioned a lot. And we don't have any of those stop words. We can also visualize this. What we'll need to do is we'll need to create a new data frame that has all of the individual ends, all of the counts. So we can do this just by, again, calling the same thing, but now storing it into a new data frame called anything you want, but we're just going to call it book 1 frequencies. So if we do that, then again, we can pipe in some dplyr. So here we are specifying that the word needs to occur more than 100 times, because any word that is only appearing like 2 or 3 times is not going to be interesting, and it's going to make our plot look messy. So we're going to pipe in some dplyr that is filtering based on the number of words and then also reordering them. So we want them to be in order of greatest to lowest, just so that it looks a little bit nicer. So if we do this, we can see that Harry, like we could already see in just when we looked at the data set, is the most common. And then if you continue changing the n, you can get more or fewer words. But this is just an easy way to visualize frequency. If you also, for example, were interested in not having names, for example, you could use filter again to filter out these people if you don't want them skewing your data set. Okay, any questions so far? Okay, so another way we can visualize is with a word cloud. The way we're going to do that is just calling this word cloud function. And again, we're just piping it in. So we're using a lot of dplyr because a lot of these functions are kind of built for the tidyverse. So if we do that, we can, again, we can see that Harry is kind of the one that's very prominent. And we can change the number of words in our word cloud by changing this max words argument. So right now we have 50 words. We can change this to 100 if we wanted. And we can also remove any words that are really skewing the variance in our words. So this is why I made sure to teach you guys dplyr first, just because it's going to be showing up so often throughout a lot of these other tidyverse sessions. And so we can again use the filter function and just remove this Harry word, and now see that a lot of other words are a lot easier to see now that we don't have one word kind of taking up a lot of the space. We can also add some nice color with this plasma color maps. And so again, this is just creating palettes that are already pre-made. So rather than calling individual shades, we can just adopt a palette. And you can do this by adding a colors argument within your word cloud. And we're going to start using this plasma color base. And so we can just run that and see that it changes the colors. You guys can also notice that there's this direction argument, and this will change on whether you want things to go from light to dark, which is the direction -1, or if you wanted it to go from dark to light, with light being the most prominent words, you can just change the sign of the direction, which is kind of cool. You can also just change the palette by just simply changing whatever the first word in this colors argument is. So now we can try this Verdus, which is more of the cool colors, pretty easily. And then we get a whole new color scheme. Okay, so that's how, just to do basic word frequencies, how to tokenize using the unnest token, and how to do word clouds. What happens if we want to look at multiple text, say another Harry Potter book? What we can do is we can read in another book. So for example, the Deathly Hallows book. And then we can do the same kind of thing. So again, we have this Deathly Hallows book that's going to have 17, has a bunch of different rows and that aren't super informative. What we can do is we can do the same thing where we're renaming a chapter variable and we're feeding in all of the text. So if we do that, sorry, my R is freaking out a little bit. Okay, so now we can see that we again have this chapter variable that's now 27, and this text has the individual text from the chapter. So we'll do the same thing again. We're going to tokenize based on words. And now we're going to pipe in directly the stop words, because we can do that all within one rather than doing it later. So we'll go ahead and tokenize and remove the stop words.
Kirsten?
Yes.
So when you were doing the chapters, how is it able to detect like what's a chapter and what's not?
Yeah, so basically all it's doing is, if you were to look at this data set, my R is a little upset with me, so it's going to be a little bit slower. What we're seeing here is that there are 37 different ones, right? And so what's actually happening is we are actually just using this one to length. And what we're doing is we're basically making this chapter just like a number based on this length. So we aren't actually like having R do anything complicated and trying to figure out what makes something a chapter and what doesn't. Basically, it's just going to take when you call this length variable, it's going to have 37 numbers. And so it's essentially doing 1 to 37, and the chapter is just going to inherit that number. So the first row will be 1, then 2, then so on. But it's not actually trying to figure out what's a chapter based on the text. Does that make sense?
Yep, that makes sense.
Okay. Once we have the second book in tidy form, what we can do is we can just bind the two rows together, because we've cleaned them such that they both already have the same column name. So they both have the names chapter and book. So we can use this bind rows and just create a new data frame that has both of them. Now this lets us do some comparisons across the two books. So we could look at, for example, like the frequencies across two books. So again, we're using things like count, but we're grouping by both the book and also the individual word. Sorry, I hope my R decides. Okay. Now you're going to get two columns, and you're going to get the top words and their frequencies. So this again, like is not super interesting for our cases. We might want to look for specific words, and in a second we're going to do sentiment analysis. But if you were interested in this for some reason, then this is how you would do it. You can also, again, compare the word frequencies visually with ggplot. So we're looking at the words that are pretty similar across the two. So in Deathly Hallows, words like sword are used very frequently, but not at all in Philosopher's Stone. So this is, again, just another way to kind of map the highly used words in both data sets and the commonly used words in both data sets. But that is basically just a quick introduction to word frequencies. So basically the idea is it's just counting the numbers of words. And like I said, if you were interested in a specific question, the filter argument, the filter verb is super helpful, and you could definitely do that. But otherwise, that is kind of what you would need to know in terms of calculating word frequencies and visualizing them. So using ggplot and then also the word clouds can be pretty helpful, because they already are using the number or the frequency of words within it. Does anyone have questions on this so far before we jump into sentiment analysis? So if we want to do something a little bit more, we can do sentiment analysis. So what that is it's basically trying to understand the sentiment of the text. So you could ask things like, how much are fear words used? Or is a book more negative or positive than the other? And the way that we can do this in R is using libraries that were built with crowdsourcing data to map words onto sentiments. And so what this looks like is you will have, if R wants to load, you'll basically have these dictionaries that have different words and then the sentiment. And so as you can see here, these all say negative, but there are different libraries that also have things like fear or happiness or joy. It's just that we can only see 10 rows here. And within the TidyText package, there are 4 different lexicons. I have 3 here because one was not working for me, this afin, but it might work on your R for some reason, but it's not working for me. 3 to 4 lexicons depending on what's working for you. And each of them have different types of libraries. So some of them are just across the negative and positive dimension. Others include multiple sentiments. So you would use different packages depending on your interests. So we're going to try a couple of them just so you guys can see the differences between some of these dictionaries. So first we'll start with this NRC. And when you guys run this for the first time, you might get a message asking whether you want to download it. Just say yes, I promise it won't do anything to your computer. Once you use this get sentiment function and then tell R which package you want to, what dictionary you want to read in, you can again just look at take a glimpse at the dictionary, and you can see we have a column that has all of the different words, and then a column that has the individual sentiment. And you can already see here that NRC has a lot more variety in the sentiment type. So we have everything from trust to fear to negative to sadness to anger. So if you were interested in a few more sentiments, then NRC would be probably a good option for you. So we can see that there are 10 different sentiments. So Bing is another dictionary, but this one is only across the positive and negative dimension. So again, we can do the same thing. We can look at it. We can just sort by unique sentiments. And see that it only has negative and positive. But how do we actually use this with our existing data? What we'll do is we're going to try and look to see what the common fear words are used at the book level. So comparing across both the Philosopher's Stone and the Deathly Hallows, what fear words are used? So we can do this again by binding the 2 books together and then counting the individual words, and then just using this mutate function to create a proportion variable. And then once we have this, what we'll do is we'll use another type of join. So this time we are going to actually use this inner join, which is keeping everything from both. And we are going to filter the NRC dataset just for fear words. And so this is important because this will just make it a little bit cleaner if we already know what our question is. We don't have to deal with all of the other words associated with other sentiments. We can just look at fear words alone. So when we do that, we will get, if it loads to load, a new data frame that has the word variables, the sentiment, and I guess this is going to be the same for everything because we've already filtered for fear words. We're going to get the book, the number, and the proportion. And so this might be interesting if you wanted to, and then what you could also do is if you were interested in, we'll talk about in a second how to test the sentiment of the book overall. But another thing that you could do is you could just look at the distribution of individual sentiments. So because the NRC dictionary does have different types of sentiments, more than just negative and positive, you could actually look at the distribution of sentiments across books. And again, we are using this inner join, but the only difference is we aren't filtering for the fear sentiments. And so if we look at this data frame, we can see that anger is really prominent in the Deathly Hallows, but about equally prominent in the Philosopher's Stone book. And so you can go through and depending on how you want this grouped, so you might actually be more interested in comparing the sentiments directly, in which case you would just change the group by order. And so now what this will do is it's first going to group by sentiment and then by group. Okay, and so if you wanted to visualize this, again, you could use ggplot, and you could just look at the proportions. And so here it's like already pretty easy to compare. And actually it seems like a lot of the sentiments are almost identical across the two, which is kind of interesting. I guess maybe because they're both from the same series, they have actually, I don't know a lot about Harry Potter, so I'm not actually sure, but maybe these would be more similar than if you had picked a random book or a nonfiction book or something like that. We can also just look at the general valence of a book. And we can do this by using the Bing dictionary, which only has those positive and negative sentiments. And so we can do the same thing here. We're just going to join our book frequency data set. And again, we're going to bind by this word variable, which is just it's the individual column that can be linked to both data sets. So if you have the word Harry in one book or one data frame, and then you have the word Harry in another, then basically these joins are taking those two instances of Harry and then binding them together and keeping all of the columns surrounding them. So we can do the same thing here, but just with a different package or a different dictionary rather. And now we can just look at the actual sentiment. So we can see that Deathly Hallows is pretty negative, and actually so is Philosopher's Stone. So both of these books seem to have mostly negative sentiment words, and roughly, again, the same proportion. So we would expect that on the basis of the NRC sentiment analysis, but now we're kind of confirming it with another dictionary. Okay, I know I'm going through this super quickly, and there aren't a ton of places to pause within that. So before we move on to using regular expressions and talking about some of the stuff that Alex mentioned earlier, like how do we actually make sure that our text data is cleaned properly? Does anyone have any questions based on sentiment analysis? I'm happy to go through any of the sections again if they're unclear.
I have another question.
Yes.
If you want to, instead of using like a preset dictionary, if you want to create your own sentiments, and I'm thinking sort of in regards to like word embeddings, if you want to like find different word stimuli to be included in this general like work category or home category, for example, would the analysis look similar to this?
Yeah, it would look
Okay.
totally the same. So if we'll just look at this, what is this Bing data frame? I think that might be helpful. So essentially, this is what, again, it's very simple. It's two columns, right? The individual word and the sentiment. So if you were interested in creating your own dictionary, and if you have specific research questions, you might already be going on mturk and having people rate words, for example. You can use all of the code that we've already gone through, but just change the database that you're using essentially. So long as the words in your dictionary map onto the words in your text database, it will work. Of course, there are going to be times where not every single word in your dictionary will be used, or not every single word within your text corpora are going to be in your dictionary. But the code will be exactly the same. The only thing is you won't need to use this get sentiments. You can just feed in your own data frame and then go through the code like usual. The only reason that we're using this get sentiments is because these packages are preloaded within the TidyText package.
Okay. Okay, that makes sense.
Yeah,
And also,
but
this
like,
is a yeah.
go
Oh
ahead.
no, I was just gonna ask. When I was looking at the Bing sentiment, I was wondering why faces was given a negative sentiment.
Yeah, that's also the problem with some of these. Like you'll find also that like Abacus was seen as like trustworthy. These have been like
Mm.
pretty heavily crowdsourced, but I would never have this be like the main analysis that you're doing in your project, but it just might be in a good initial sense. And then if you really are interested, then what you would probably want to do is you would probably want to vet this for yourself. So there might only be a subset of words that you actually want to use, and it's pretty common to not use all of the words within a dictionary. So, having 7,000 words is probably, a lot, especially when some of them might not be used. So yeah, this is definitely not a perfect science, but as you can see, it's only a couple lines of code. So it's something that can be done pretty quickly and is a super great initial test if you're just kind of curious. So one of the ways that I've used just like word frequencies recently is I had an open-ended question asking people to provide like more information they would want to know about a juvenile defendant. And then basically what I did is I just tokenized the words and also the sentences and just could get a sense of whether people were talking about different things depending on whether defendant was white or black. And that was just kind of an initial sense to see whether I should do things like topic modeling or word embeddings or just like trying to get to dive into the data more deeply. But I think word frequencies, word clouds, some of these sentiment analyses are something that are great complements. But like you said, for their shortcomings, unless you're going to really put a lot more effort into them, they probably aren't going to be like something that are super, super prominent.
Okay, cool. Thank
Yeah.
you.
Does anyone else have questions about sentiment analysis? Okay. So then we're going to jump into these things called regular expressions. So what is a regular expression? A regular expression is just a pattern that describes a set of strings. And the reason that we like regular expressions is that they save a lot of time. So for example, if we wanted to remove or find all of the punctuation, that's something we've talked about earlier. We might want to remove punctuation. Rather than having to call each individual punctuation symbol, we can just use this punct kind of, I don't know what you want to call this, but like we can just use this regular expression. And so as you can imagine, this saves a ton of time. I've included 2 cheat sheets and they go through really nicely all of the different types of regular expressions. So I like to use regular expressions both from string R, which is another tidyverse package, as well as just some of the base R regular expressions. And the reason I'm not talking through them thoroughly is just because there are so many. And in order to really understand regular expressions, I think the best way is just to try it for yourself and get a sense of which ones you like using. A lot of them do similar things. It's just a matter of preference often. But I'm going to go through the ones that I think are most important and the ones that you should and probably will encounter most. But those resources are if you want to reference them. I almost always have to look up some of these expressions, so don't feel bad if you have to use the cheat sheet while you're coding. It's definitely a resource that you can and should use. But when would you use regular expressions? So we've already talked about that maybe for punctuation it might be nice because then you don't have to go through by hand and remove each of those individual punctuation types. But let's go through it with an example. So say you were looking at Trump's tweets and you wanted to use the pattern MAGA and you just wanted to make some inferences about his usage of it. So you might be interested in detecting this pattern or counting it. So looking at his tweets and trying to understand like how often does he really say MAGA? You could use regular expressions. And we're going to go through all of these later, but I'm just going through the top 4 in my opinion. You might also be interested in just subsetting all of the tweets that include MAGA. So when he does use hashtag MAGA or mention MAGA, like what is he talking about? So you could just subset every single tweet that mentions this pattern, MAGA. You could also replace the MAGA. Say you were giving this to someone who doesn't really know what MAGA means. You could replace that pattern so that every single instance of MAGA now says, "Make America Great Again." You could also just replace the pattern with nothing or ... or no, whatever you wanted. But I think these kind of 3 are the most important ones that you'll encounter, along with one more that I'll talk about. But these are just kind of the general scenarios in which you might be interested when you're trying to detect a pattern, when you're trying to subset or remove a pattern. So does anyone have any question just on like what a regular expression is still? Okay. I have already downloaded, I don't know if you guys are familiar with this, but there is this website called Trump Twitter Archive, and they basically are storing all of Trump's tweets. You can, within the website, search for things within it, and you can also download the tweets, which is kind of cool. So I've downloaded, I can't remember how many weeks I've downloaded, but I downloaded a fair amount of tweets, and so you guys should be able to read this in as well. But I've already done a little bit of cleaning on it. But as what you can see, if we just view this, is we get a couple different columns. So we have the source, we have the individual text, which is the tweet. We've also have things like how much it was retweeted, how much it was favorited, things like that. And so something that I've done with this data at one point is I was actually just interested in what Trump was tweeting about. And so I basically, at different times of the day, and how positive or negative it was. And so you have to do some wrangling to get this to be a time that makes sense. And if you are interested in looking at things like this, let me know and I'll email you the code. But you can do things like looking at when he's tweeting most. And when I did this, he was actually tweeting most after listening to Fox and Friends and things like that. So it was kind of just funny. But again, we'll do the same kind of basic test to make sure the data is looking good. So we can just check out the dimensions. We can see that we have over 3,000 different tweets across 7 columns, which we talked about. Can, again, just like use glimpse or class to make sure that the data, that this text variable is in fact a character, which is super important for anything we want to do, like we talked about earlier. And then this is super, super important. Whenever you're working with text, make sure that you are changing the string to lower. This is so important because R is case sensitive. So if you are wanting to look at individual words or patterns that have words, you're going to need to do this, because otherwise you would have to have multiple lines of code for each different combination. So it's possible that Trump would use like very bad, sometimes very could be the first word, so the very would be capitalized, sometimes it would be the middle. And so you just save yourself a ton of time if you make everything lowercase, and so you don't have to worry about whether you're missing words or missing patterns because of that. And so like I said, there are a bunch of different things you can do with regular expressions. So regular expressions typically follow the same kind of pattern, no pun intended. So you kind of have the task here. So this is what you want to happen. So now we're going to just detect the strings. And then the first argument is typically the column that you want to search. So we're interested in the text column because that's where the individual tweets live. So if you just called this column and then then this right here is your pattern. So we're going to search for MAGA, but you can also include regular expressions here. So things like punch. This can be anything. It doesn't have to be just words, but I think because it's a little bit more interesting for us, we'll just do this. So when you do string detect, what you're going to see is a bunch of true falses. And this is, like, I guess, kind of informative because you can tell that tweet number 888 had MAGA, but this is not super informative or helpful. So something else you might want to do is just actually count the number of MAGA tweets. So you can do this with just this string count. So again, it's following a very similar pattern where you have the type of task you want to do, you have the variable you want to search, and then you have your pattern. So if we were to then just count the number, we could see is we have 50 instances of MAGA within our tweets. Okay, like that's not huge. We could do the same thing with very bad, which is something that he seems to like to say. Okay, only 9 instances, not too much. But we can also just subset based on a string. So what subset setting means, if you're not familiar with the term already, is it's basically going to take your data frame and pull out or subset anything that matches the pattern. So here what we're going to do is within the Trump tweets, we're going to look inside the text variable and we're going to pull out only tweets that have the word MAGA in it. So when we do this, we now have, and again, like I'm renaming the data frame so that we're not writing over this. Now we have all of the tweets where he is included MAGA. And you can see that it's almost always hashtag. So he's saying hashtag MAGA. Yeah, I guess pretty much in every case. But we can, again, use this length. So like I said earlier, the length is really just counting the number of rows to see that he's mentioned it 49 times. And we can also use, okay, so I guess let me pause for a second. So the ones we've gone over so far are string to lower. So making everything lowercase. You can also make everything uppercase. You can also do string to title, which would make everything a title case if you are interested in that for some reason. We've talked about string detect, which is simply detecting whether or not a pattern is in the specific tweet. And so that's going to give you just true falses. We talked about string count, which is counting the number of instances, and we've done this string subset. So based on this so far, does anyone have questions about how to use these regular expressions with patterns?
Yeah, I have a question.
Yes.
Yeah, so if you look at the string detect function, you said it returned true and false values, but if you scroll up in the console, there were a lot of NA values as well. So what would cause those values to actually show?
Yeah, so I noticed that within the data set, there were also some weird ones that were like just links and stuff. Here, let's actually, we can look at that again. So what we'll do is we'll try and find the first NA value, and then we'll look at it within the data set.
Mm-hmm.
Okay, so let's just look at line 76 because that will be easier to find. And we can see what's going on. Okay, so it's just empty is why.
Okay.
I don't totally know why this would be empty. It seems like maybe the Trump Twitter archive just had like a couple of mistakes because
Maybe.
this seems like this should have been a tweet like average earnings up 2.9% this year. So it's possible that Trump had some weird symbol or something in his tweet and that's messing it up. But yeah, it's only there. Okay, so that's actually super weird. I haven't noticed that because I haven't gone through all like 3,000 entries. But yeah, so I guess the answer is that they are just are empty values, and so that's why they're NA.
Great, thank you.
Yes, no worries. Good question. Weird.
It looks like, I just looked up the tweet. It looks like it's emojis, yeah.
Yeah, okay. So that's interesting, and I guess you would probably want to use regular expressions to fix that before you were interested in actually searching for any patterns. Thanks for searching, Alex. Okay. Any more questions on these subsetting, string to lower, any of these that we've gone over so far? Okay. So now we're going to do a little bit more cleaning. So right now we've just so far mostly been looking at the instances of certain patterns, but text data is pretty messy. So there are almost always you're going to need to do some cleaning. So we're going to just create a new data frame here, just so we aren't writing over the original one. But we're going to use the string remove function a lot. And so as you can imagine, what this is doing is it's going to remove whatever pattern you've specified. So like I said, you can have both an individual word or letter or anything you want here. So we might be interested in removing all the @ symbols for when he is adding people within his tweets. So we can do this just by using string remove. But we can also use regular expressions. So if we were interested in something that we needed to remove all punctuation, rather than going through and actually specifying that we want to remove all periods, all commas, all colons, all semicolons, all of these things, we can just within the pattern include this regular expression here. And that's why they can save a lot of time. So now we can just remove all of the punctuation. So we can look at this to make sure it's working properly. Sorry, my computer is just really overheating, so it's being a little slow. Okay, we're still seeing like, that's weird. Okay, so this is a case of using remove versus remove all. I didn't think it would work with punctuation, but this is something that I was actually going to mention with the replace all. There are a couple different types of each different remove or each different replace. So when I didn't have this remove all, what was happening is it was removing the first instance of punctuation within the tweet. And I thought it wouldn't do that because I'm using a regular expression, but the only thing I've changed now is I've added this underscore all. And now what that's doing is it's going to remove all of the punctuation from the sentence. So I was gonna show you that with this next line. So here we might be interested in removing or replacing this retweet with nothing or with a space. And so we can do that with this string replace. But what I was going to show you is that if you actually count the number of instances, you can still see that there are 150. And that's because even though typically retweet goes at the beginning of his tweets, there still were some there. And so I was going to mention that if you use replace all, then it's going to replace all of the instances, versus just string replace is replacing just the first instance. And so when we do this replace all, if we count again, we can see that now we have 0 instances, which we want. We can also use things like grep, which is just another pattern matching tool to actually subset our data frames. So here, you'll notice that for grep and grepl, which we'll talk about in a second, you have to flip the order. So rather than having the variable first, we have the pattern first. So we can just create new variables or new data sets based on all of the tweets where he says things like terrific, success, great. And then if we look at them, now we have all of the tweets where he's saying these words. We can also nest things like grepl within our case when function to create new variables. So if you guys remember, case when is kind of like an if-else statement, except instead of having to nest individual if-else statements within each other to create more than 2 categories, what we can do is we use this pattern. So you have something and then you create the individual level here. So as you can see here, I have 4 different words. So in R, this means the straight line means or. So what I'm doing here is I'm saying if within Trump tweet, the text column, which is the tweets, if it says terrific, or if it says success, or if it says great, or if it says fantastic, then make the level within this happy variable called happy. And obviously this is a super simplistic version of what you might be doing, but I've used this recently when I'm trying to understand text responses to a surgeon riddle, and the key DV is whether someone says that the surgeon is the mother. And so using these grepl to figure out whether someone is talking about a mistaken identity or a mother or a stepfather, it was super helpful. So again, we're using more dplyr in addition to some of these base R or regular expressions. And then we can actually just look, okay, And then something that we might want to do is then, based on the instances where he is using these words, we can just look at what those tweets are. So again, we'll be using more filtering and more, and I'm just going to select only the tweet variable and only the ID variable, which just so to make sure that we are keeping track of what the tweet is, to actually see what he's tweeting about when he's using these words. So we are basically out of time, so I won't go through them, but this is just kind of a general overview of the ways in which you can use regular expressions, the different types of ways that you might use them, and then how you can actually combine some of these regular expressions to do things like make new variables or manipulate data also within the tidyverse and deploy our framework. All right, that's everything for today, but make sure you check out the test yourself exercise as well as the other resources related to this topic. Specifically, we have a couple of cheat sheets as well as other resources to aid your text analysis endeavors.